How the humble pencil quietly shaped modern science. There is a tool so ordinary that most people reach for it without thinking, and yet its story touches everything from the exploration of the Arctic to the development of modern chemistry, from the drafting rooms of engineering firms to the desks of philosophers who could not afford to make a mistake. The pencil is one of those inventions that became invisible precisely because it worked so well. The story begins in 1565, in a place called Borrowdale in the Lake District of England, where shepherds noticed something unusual after a violent storm had uprooted a large oak tree. The exposed roots had left a dark deposit in the earth, a substance that was slick, dense, and extraordinarily useful for marking sheep. The shepherds called it black lead, because it looked and behaved a little like lead, though it was not lead at all. We now know it as graphite, a form of crystallized carbon that forms naturally under conditions of intense geological pressure over millions of years. The Borrowdale deposit was extraordinary, unusually pure and solid. It could be cut into sticks and would leave a clean, dark mark on almost any surface. Within decades, word of this material had spread across Europe, and people were wrapping it in string or stuffing it into hollow reeds to make it easier to hold. The pencil, in its essential form, had arrived. For the first 150 years of its existence, the pencil was primarily a tool of the workshop and the counting house. Architects used it to sketch plans that could be revised. Engineers used it to draft schematics. Merchants used it to keep ledgers that could be corrected if a figure was wrong. This seems obvious now, but it represented a genuine shift in how people related to recorded information. Before the pencil, most writing was done with ink, which dried and was permanent. Mistakes were serious. The ability to mark something down provisionally, to sketch, to plan, to estimate, to erase, changed the tempo of intellectual work. It introduced a kind of tentativeness that was in fact a form of courage, the willingness to put down an idea before you were certain of it, because you knew you could refine it later. Scientific notebooks from the 17th and 18th centuries show this shift clearly. Margins fill with penciled annotations. Diagrams are sketched, crossed out, and redrawn. The provisional thought becomes normal. By the late 18th century, the Borrowdale deposit was beginning to be depleted, and England, which had controlled the world's best graphite supply and guarded it jealously, was less willing than ever to export raw material during the Napoleonic Wars. France found itself with a serious problem. Its armies and engineers and draftsmen needed pencils, and quality pencils had largely come from England or from Germany, which imported English graphite. In 1795, a French engineer named Nicolas Jacques-Conti solved the problem in a way that turned out to be more important than the original discovery. Conti found that by mixing powdered graphite with clay and firing the mixture in a kiln, you could produce a writing core of consistent quality. Adjust the ratio of graphite to clay, and you could control exactly how hard or soft the pencil would be. The modern grading system, the H for hard, the B for black, the numbers that run from the palest hard line to the deepest soft mark, descends directly from Conti's insight. He had not just solved a supply problem. He had turned a natural curiosity into a precision instrument. The precision that Conti introduced made the pencil indispensable in two fields that would define the 19th century: military cartography and scientific observation. Surveyors mapping unknown territory, the American West, the Arctic, the interiors of Africa and Asia needed a tool that would work in freezing cold and driving rain, that would not leak or freeze or require a fire to prepare. The pencil asked almost nothing of conditions. Explorers' journals from the great age of geographical discovery are written largely in pencil, and the faintness of some of the marks, softened further by decades of handling, gives them a quality of almost having been dreamed. The same qualities made the pencil central to scientific fieldwork. Charles Darwin made notes in pencil during the voyage of the Beagle. Michael Faraday sketched his early intuitions about electromagnetic fields in pencil in his laboratory notebooks. These were not final thoughts, they were thinking made visible, half-formed ideas given just enough substance to be examined and developed. The pencil let science be tentative in the way that good science has to be. For most of its history, pencil making was a craft. Cedar wood was shaped by hand, a groove was cut down the center, a graphite core was laid in, and a second piece of wood was glued on top. The whole thing was then planed and sanded and finished. It was slow and skilled work. In the mid-19th century, a company in Nuremberg called Faber, later Faber-Castell, began industrializing the process, using machines to cut and shape the wood and to mix and extrude the graphite cores with a precision that handwork could not match. The price dropped dramatically. By the end of the 19th century, pencils were cheap enough that every schoolchild in the industrialized world could afford one, and literacy campaigns and universal schooling were built partly on this assumption. The democratization of the pencil is one of those quiet episodes that historians rarely pause over, but it matters. When writing instruments became cheap enough to give to everyone, the idea that everyone might have thoughts worth writing down became easier to take seriously. The pencil has survived the arrival of the ballpoint pen, the felt tip, and the digital stylus. It survives because it does things other tools do not. It works in extreme cold that freezes ink, it can be sharpened to a point fine enough to draft technical drawings with precision, and it can be erased, not deleted with a keystroke, but erased slowly, with the grain of the paper still visible, the ghost of the original mark remaining like a memory of an earlier thought. There is something in this that people find useful not just practically but psychologically. The pencil suggests that what you are putting down is not final. It invites revision. It says, in its quiet way, that you can think again. In a world that increasingly favors the permanent and the publishable, that is not nothing. The pencil has been here for 4.5 centuries, and it has not run out of things to teach us about the value of starting somewhere and seeing what happens.